Welcome to Week 2 of Introduction to Algebra. This week we'll be discussing 3 topics: order of operations, one-step equations, and translating words to expressions. Most students are familiar with the order of operations, and most students have learned to remember the phrase PEMDAS. PEMDAS stands for parentheses, exponents, multiply, divide, add, and subtract. Many students have learned the expression, "Please excuse my dear Aunt Sally," as a memory trick to help remember the order of PEMDAS. However, parentheses are only one form of grouping symbols. It is most appropriate to say that grouping should be done first, and this might include parentheses, brackets, or a fraction bar. So instead of PEMDAS, we should remember grouping first, followed by exponents. You then multiply or divide in order from left to right, and you add or subtract in the order from left to right. So instead, students need to learn the new expression, GEMDAS. Students should take notes on this portion of the video in their math, dictionary, and reference book. Start the first page for Week 2 with order of operations. Be sure to include grouping, exponents, multiplying or dividing in order left to right, and adding or subtracting also in order from left to right. Our next topic is solving one-step equations. For one-step equations, start a page in your notebook with a table having 3 columns for operation, inverse, and example. The first operation that we are going to discuss is addition. When we add, we may have a problem such as x plus 5 equals 15. This is an addition problem. To solve this problem, we use the inverse operation of addition. So instead of adding, we subtract. That means you subtract the constant from both sides of the equation. So x plus 5 minus 5 equals 15 minus 5. Our solution becomes x equals 10 when simplified. If we start with the subtraction as our operation, so we start with subtract, such as a problem like x minus 8 equals 12. The inverse of subtract is add. So in order to solve this one-step problem, this one-step equation, we want to get x by itself. Since I have x minus 8, the inverse is to add 8 to both sides. Students often think of this as adding the opposite. I have x minus 8 equals 12. I add 8 to both sides. Negative 8 plus 8 is 0, and I'm left with x. 12 plus 8 is 20. So I'm left with the answer of x equals 20. This is often referred to as isolating the variable. Our goal here is to get x all by itself. If the original operation that I start with is a problem that involves multiplying, such as 3x equals 15, this means 3 times x equals 15, then the inverse of multiply is divide. And in this example, I would divide both sides by 3. So 3 divided by 3 cancels out to be 1. 15 divided by 3 is 5. I have isolated the x by itself, and I end up with 1x equals 5. That's my solution. If my original operation is divide, and I start with a division problem, such as, for example, x divided by 4 is equal to 12. I use the inverse operation. The inverse of divide is multiply. So in order to solve this problem, what I want to do is multiply both sides by 4. This means I start with x divided by 4 equals 12, and I multiply both sides by 4. You can think of 4 as 4 over 1. So these 4's cancel, and I'm left with 1x equals 12 times 4 is 48. And that would be my solution. Translating words to expressions. You're going to create a page of notes that looks like this. In my tablet here, I needed to use 2 pages. You'll see these in the upcoming slides. A section for addition, a section for subtraction, and on the next page I have sections for multiplication and division. So for translating words to mathematical expressions, when we're talking about addition, what you need to be able to do is read a written description of a mathematical situation, and you need to be able to translate that into a math expression. Words that you commonly use for addition are sum, increased by, more than, greater than, in addition to, phrases such as that. So for example, if I have the sum of 8 and a number, that can be written as 8 plus n or n plus 8, in which n represents the variable. A number increased by 7 can be written as n plus 7 or 7 plus n. 5 more than a number can be 5 plus n or n plus 5. And 3 greater than a number can be written as 3 plus n or n plus 3. Notice that with addition, there are 2 ways to write these 2 examples. It does not matter the order in which we add numbers or variables, because addition has the property of being commutative. Therefore, it's really not important whether I write 3 plus n or n plus 3, because they mean the same thing. Subtraction, however, is not commutative, and it is actually very important to make sure that you put the correct variable or number first. So you have to pay very close attention to how the written expression is stated. So for example, the difference between a number and 4 puts the number first, minus 4. A number decreased by 8 means you start with the number and you subtract 8. 7 fewer than a number means that I start with the number and I take away the 7. So even though 7 is first in the written words, the written expression, in the mathematical expression, the 7 is second. 5 less than a number is similar. I'm starting with a number, which I'm calling n, and subtracting 5. 6 minus a number starts with 6 and subtracts the number. And 9 diminished by a number means I start with 9 and subtract n. With subtraction, read the written words very carefully and think hard before you write the expression to be sure that you have the numbers and variables in the proper order. Multiplication is similar to addition in that it too is commutative. So the product of 4 and a number is written as 4n. Technically, it could also be written as n times 4, but it's tradition that we usually put the coefficient or number first. 7 times a number is written as 7n. 1/3 of a number is written as 1/3 times n. When you see the word of, always think multiply. And a number doubled or twice a number is 2 times that number. Division is not commutative. Like subtraction, the order is very important. If I have the quotient of a number and 8, I start with a number and divide by 8. You can write this using the division symbol, or you can write it as a fraction, because n over 8 means n divided by 8. A number divided by 10 is n divided by 10, and a number halved would be n divided by 2. That could also be written as a fraction n over 2. Thank you for watching this YBARC production.